So the ability to think quantitatively, I think, is one of the most important skills a young person can have. And by thinking quantitatively, I don't just mean being fluent and comfortable with various mathematical formulae or doing well in one's mathematics coursework. I'm going to be able to look at various problems and frame and understand them quantitatively and be able to arrive at the correct answer efficiently and know how they got there. So I thought that we'd take a look at one of my favorite sort of examples that I've used in the past to help students sort of get more practice thinking quantitatively. This is I believe is a GMAT problem. It's got, of course, it's multiple choice problems. So let's look at a couple of, I'll just write 3 multiple choice options here, answer choices, even though there's usually 5. Let's say the first option is, let's say it's 2 to the 10th. Let's say the second one is 2 to the 12th. And let's say the third option is 2 to the 32nd. Like I said, I've shown this problem to a lot of students, and many of them have looked at it, and right off the bat they didn't like it. They thought it was unwieldy. I think a few thought it was frightening for a couple reasons. One's mentioned that then, working with exponents can be messy, and it's just it just looked like it was going to be very time consuming. And frankly, a lot of them just didn't know how to approach the problem. And so that just made them freeze and sort of just feel kind of paralyzed at the outset. And I said, okay, no worries. Just relax. Don't worry about it. In fact, forget about this actual problem for a second. Let's just look at this example that I have that I think will help elucidate sort of how to approach this problem. And so I said, all right. Let's just, instead of that problem, let's look at this one. 7 plus 7 plus 7 plus 7. I think most folks would look at this and within a second or two be able to say that the answer is 35. And they would be right. But what is it that they're actually doing that allows them to arrive at the correct answer so quickly? What they're not doing is they're not making this an addition problem, even though it looks like one. What they're actually doing is they're transforming this unwittingly into a multiplication problem. And so instead of actually saying, okay, 7 plus 7, that's 14, plus another 7, that's 21, plus another 7, that's 28, plus another 7, that's 35, instead of doing that, they're saying, okay, I see 5 7s there, and I know what 5 7s are. That's multiplication, and that's 35. So what they're doing mathematically is they're, factoring out a 7. Of course, they're not actually doing this. They don't even realize that they're doing this. But I guess what allows them to do this mathematically is this operation, factoring out a 7, and doing this operation where we get 5 1s inside of the parentheses. And so before you know it, you've got 7 times 5, which equals 35. And so that should give us a pretty good foundation from which to approach this problem. So probably many of you who are watching this video have already sort of solved this problem in your head without even putting pen to paper. And so, like I said, what we're doing is by thinking quantitatively, we understand this problem well enough to know what we can and can't do and what we don't have to do. And in this case, we don't have to make this an addition problem. We can make it a multiplication problem. And so that's what we're going to do. So 2 to the 8th, we'll factor out a 2 to the 8th. And before you know it, we'll have 4 inside, in the same way that we had 5 inside the parentheses up there. So you have 4 ones in here. Sorry, my pen has got a bit of a lag. So 2 to the 8th times 4. Of course, we can't simply multiply 2 to the 8th times 4 because it doesn't work that way. In order to add exponents, we need to have the same base. Luckily, that's very easy once we realize that we can simply convert 4 to 2 squared. Well, now this problem is basically done because 2 to the 8th times 2 squared is the same thing as 2 to the 8th plus 2, or 2 to the 10th. And so, we can tell pretty quickly that the correct answer is A. Correct answer is A, 2 to the 10th. But I want to stress that the real value of becoming more practiced at thinking quantitatively isn't just arriving at the correct answer choice on a standardized test faster. It's being able to feel more confident with problems that look a little bit unwieldy and not not user-friendly, if you will, and being able to say, no big deal. I understand how to think quantitatively, and I'm used to doing it enough that I know that I'll be able to sort of reason through this problem and know what I can and can't do and what I don't need to do so that I can arrive at the correct answer and then know how I got there.